already have it memorized, and then you don't need to get it out. So let's get out our green sheet, and we're moving on to our 4.2 notes. We are going to find the value of all 6 trig functions. All right? So there are 6 of them. We have sine, cosine, and tangent. Those are the big 3. If you look at your calculator, you know you have those buttons. But then there are what we call the reciprocal functions. The reciprocal of the sine is the cosecant. This is all on your green sheet. The reciprocal of the cosine is the secant. And the reciprocal of the tangent is the cotangent. So you need to know what they are, what their abbreviations are. Theta, remember, is a variable. So this is like finding what's the sign of x. What's the sign of my angle? Okay? Now, what are we given? Well, in problem A, we are given this right triangle. Okay? But something's missing in that right triangle. We're missing this side. Right here, right? And we gotta have it to answer all these questions. So, how are we going to find the missing side of the triangle?
So.
Pythagorean theorem.
Oh.
So, I don't know what you want to call this, I'll just call it that. 2 squared plus x squared equals 5 squared.
Yep.
This sounds really silly that I'm even telling you this, and I don't mean to insult you in any way. But when you do the Pythagorean theorem, this guy over here is the hypotenuse. Okay? This is the hypotenuse. So 2 squared plus x squared equals 5 squared. So 4 plus x squared equals 25. X squared equals 21. And x equals the square root of 21. Okay? Fog is clearing, memories are coming back. Now, yesterday you told me that you remembered SOHCAHTOA. You can write this on your sheet if you want. That sheet's yours, you can write whatever you want on it. SOHCAHTOA. Okay? What does the O stand for? Opposite. Now, this is where your picture is incredibly important, because this side will always be the hypotenuse, always. But the other 2 sides, opposite and hypotenuse, are in reference to wherever your angle is. So since my angle is right here, this is the opposite side, across the triangle. And then this one, which is right next to the angle, is the adjacent side. This is not always the opposite side. The opposite side is the one that's across from the angle, so you gotta pay attention to where your angle is. Not touching the angle, right? Adjacent touches it. All right? Now, if you can label your picture and you get SOHCAHTOA, these are easy. Sine, opposite over hypotenuse, 2/5. Everybody see that? Cosine, adjacent over hypotenuse, root 21 over 5. And tangent, opposite over adjacent, 2 over root 21. Which will clean up and say 2 root 21 over 21. SOHCAHTOA gives you your big 3. O opposite, A adjacent. h hypotenuse. Right? Now, to get the other ones, all you have to do is remember that the cosecant is the reciprocal of the sine. So if the sine is 2/5, then the cosecant is 5/2. The secant is the reciprocal of the cosine. So 5/√21, or 5√21/21, if you rationalize it. And then the cotangent is the reciprocal of the tangent. Now, for this one, flip it right here. Because if you flip it here, you're going to get √21/2, which is okay. If you flip it here, you're going to have to clean it up. So flip it right there in that stage. Now, something I never thought about until a couple of years ago, because the kids, were memorizing this stuff, and kids were saying, I can't keep straight, what's the reciprocal of the sine, da-da-da. And a student said, remember, the cos never go together. So in other words, we have sine and cosecant. So in that pair, there's one co. And then we have cosine and regular secant. See what I'm saying? And then we have tangent and cotangent. So there's one co in each reciprocal pair. Sine, cosecant. Cosine, secant, tangent, cotangent. I don't care how you remember it, but you gotta remember it. You gotta remember that the sine and the cosecant are reciprocals. Okay? Alright, now, let's try B. B is exactly the same thing, except it's got a different picture. So let's try B. Who can remember what we need to do first? We need to find the missing side, which this time is the hypotenuse. So 3 squared plus 5 squared equals x squared. 9 plus 25. Looks like my hypotenuse is the square root of 34. You will never have to do this without a baby calculator. So if you're concerned about adding 9 and 25, you'll have a baby calculator if you need. All right, let's label our sides so we get it right. This is, of course, the hypotenuse. What's 5? Adjacent. Very good. And 3 is opposite. Look at your picture, guys, and make sure you understand that. It's all based on where your angle is. All right, let's fill them in. What's my sine?
It's 3√34.
3, it starts out as 3/√34, but you're right, that's 3√34/34. What's my cosine?
5√34/34.
Yep. So, Katoa, what's my tangent?
3/6.
3/5. Now, what happens in the other column? We just flip. And when you flip the unsimplified form. So what's the cosecant? √34/3. And the secant is √34/5. And the cotangent is 5/3.
Don't you type it in the calculator, like, is divide, like, I remember doing geometry, you would, type the numbers in.
Well, certainly, we could type these numbers in our calculator and get decimals. Right now, we're doing everything without a calculator. We will be doing decimals on our calculator for sure. by the way, speaking of that, do you have a cosecant button on your calculator? No, you do not. So you don't, I'm just telling you, you don't. The only way to find a cosecant is to remember that cosecant is 1 over the sine. So even if you have a calculator, there's a certain amount of memorization you simply have to have. All right, so one thing you can start focusing on is your reciprocal functions. Sine is reciprocal of cosecant. Get those pairs learned. Okay, let's look at number 2. Same thing, only this time, they didn't really draw a picture for me. They told me that the secant is 3/2. Now, what does that automatically tell you? That the cosine is 2/3. So adjacent is 2 and hypotenuse is 3. Now, remember yesterday we talked about standard position? When I draw a picture for you like I did in part 1, you just go with whatever picture you're drawing. But if you have to draw your own picture, which we do in this problem, we're going to put it in standard form. So the angle is going to be at the origin, and our triangle is going to be sitting on the x-axis. That's the initial side. Okay. Notice that I don't continue to draw pictures for you. You need to know this is the way you're going to draw every picture you draw. If I don't draw for you, this is how you're going to draw. Okay, so in this picture, I know this is the hypotenuse. Which side is this? Adjacent. And this is opposite. So I know that adjacent is 2 and hypotenuse is 3. So now I'm right back to where I was a minute ago. I need to find my opposite. Remember, that's the hypotenuse. So 2 squared plus x squared equals 3 squared. So 4 plus x squared equals 9. It looks like this is root 5. Would you agree?
Yeah.
Now we can fill everything in. So Katoa, sine is opposite over hypotenuse. And tangent, cosine's already done, so tangent is opposite over adjacent. Everybody good? So now we'll do the reciprocals. The cosecant is the reciprocal of the sine. And the cotangent is the reciprocal of the tangent. So you see what I mean when I said this is pretty easy, there's a lot to remember? It really is easy. Very easy. All right, so you try B right now. You and your partner try 2B. Draw a picture just like this and label it accordingly.
The other way.
Opposite or adjacent.
It's always reassuring when the teacher is right. Aiden, you got this? Good for you. Ronan, with the program here? Alright, how about my talkie boys back there? You guys got it?
Yeah, we're good.
Good? London? Everybody good? Alright. Now we're going to something different.
Overhead.
Now we're gonna find the exact value of the sine of pi over 3. Now, no calculator, no calculator. Now you still need your green sheets. The sine of pi over 3. So let's think about what we talked about yesterday. Pi over 3 is a radian measure. Can you tell me how many degrees pi over 3 is? 60. Why is it 60? Because pi is 180. Remember that from yesterday? Pi is 180. And if pi is 180, then a third of pi will be a third of 180, which is 60. So this problem is really asking me to find the sine of 60 degrees. Okay? Now this is the first point where we could have confusion, and I don't want to have any. When we are doing navigation, that is, when we are using our compass, angles are measured like this on the compass. The only time angles are measured that way, the only time, is in navigation. So if somebody's giving you directions, a ship, plane, this is how you're going to set it up. Every other time, your angles are in standard position. So they start, the vertex is at the origin, and they start here. So 60 degrees is going to look like this. This is 60 degrees. Because in standard position, 0 is here. I know it's confusing, I didn't make the rules. That setup is only used for compasses, period. Every other time, you start measuring here, and you go up and around. So this would be 90, 180, 270, and then back around to 360. Okay, every time. So if we're doing 60 degrees, it's going to be between 0 and 90, right? Right in there, 60 degrees. Now, I want you to drop a perpendicular straight down to the x-axis so that you have a triangle that looks just like the triangles in our previous problem. Only now we know that that angle is 60. And that angle is obviously 90. So this one is 30. So you have now one of your special triangles, 30, 60, 90. And you remember that the sides are in a particular ratio in a 30, 60, 90 triangle. In a 30, 60, 90 triangle, and this is on your green sheet, across from the 90, the hypotenuse is always 2. Across from the 30 is 1, and across from the 60 is √3. Those don't change. Those are fact. You learn them in geometry, you're learning them now. Short side is half the hypotenuse, remember that? Short side is half the hypotenuse. 1, 2, √3. Now, the angle, your 60, or whatever it is, will always be at the origin. That's where theta goes, at the origin. So which side is this? Opposite, adjacent, or hypotenuse?
Opposite.
That's opposite. This is adjacent, and this is hypotenuse. Now, what do I want? I want the sine. So katoa. sine is opposite over hypotenuse. So the exact sine is root 3 over 2. Wow, that's a lot. But it's also one of the most important pieces of the whole thing. Knowing how to do that is going to come up over and over and over again in other problems.
So can you explain why, like, the zeros on the right are 180 and 270 over that?
It's how they are. That's called standard position. It's called standard position. That's how they're labeled.
Why isn't 0 where 90 is?
It's standard position for angles. It's universally labeled here. That's what it goes. Yeah, I didn't write the rules. The rules. All right, let's look at the next one. All right.
Oh, okay, that makes sense.
Secant pi over 4.
So really for H grade.
So secant pi over 4. All right, so pi is 180. So a fourth of it would be
45.
45.
45.
So we're going to draw our triangle right there in quadrant 1 again, 45, right there in the middle. Always put your angle at the origin.
Root 2.
So we've got a 45, 45, 90 this time. Would everyone agree with that? In a 45, 45, 90, which is an isosceles right triangle, the sides are in the ratio 1 to 1, the legs, and the hypotenuse is root 2. We've got adjacent, opposite, and hypotenuse. Remember, this is your angle right here. And we want secant, which is the reciprocal of the cosine. So if cosine is adjacent over hypotenuse, this guy is going to be hypotenuse over adjacent. So root 2 over 1, the answer is root 2. Isn't this fun?
Man.
Yeah.
All right, let's see if we can get the next two done. Tangent pi over 6. Tangent pi over 6. That'll be the tangent of 30. Would everyone agree with that? Pi is 180.
Yes.
All right, you gotta get the right angle. Everybody good with 30? So here's my picture. Look at my picture. Is that good? This is 60 up here. This is the one I look at. So across from the 30, tell me about tangent. What's tangent? Toe up. So opposite over adjacent. Remember, that's your angle. So opposite's over there. So my answer is 1 over root 3, or root 3 over 3. Okay, that took 1 minute. I went kind of fast. Anybody have a question about any of those steps? Ronan?
I'm confused about the numbers on the outside. Like,
You gotta memorize them. Across from the 30 will always be 1. Across from the 60 will always be root 3, and the hypotenuse will always be 2.
is that the same depending on, is that like depending on the different degrees?
Yeah, that's a 30, 60, 90
Oh,
setup.
wait, yeah, I see it here.
Yeah, we're either, the only triangles we can do like this are 30, 60, 90, 45, 45, 90.
Okay.
So those are the two you're responsible for knowing. All right, last one, cosine pi over 3.
60, 30.
Cosine pi over 3 is the cosine of 60. So here's my 60. Now again, remember, the angle you're doing is the one at the origin. So 60 is at the origin, which means 30 is up here. So 1, root 3, 2 this time. cosine 60 is adjacent
Wait,
over
can you explain that
hypotenuse.
again, like for the root three?
Across from 6 over.
Oh.
Yeah, you gotta memorize those, Jake. You gotta memorize them.
No,
So you
I
go.
was wondering, cause like, it's across, okay, it's across from six, six is down there,
Yep, yep.
I don't know if it's always,
No,
what's that, root three over two?
no.
One half.
One half.
One
That
half.
is-
No, I
Hey, if you have your calculator out just for fun, type in cosine 60. Oh, imagine that. 45, 1/2, cosine 60. All right. Yeah, homework 4.1 is due on, what's today? Thursday. Yep, due